Greibach Normal Form. A context-free grammar G where you have variables, terminals, productions and a start symbol is said to be in G and F if every production is of the form capital A can be replaced by a small a and alpha, where capital A is your non-terminal and your small a is a terminal. So followed by a alpha, where a belongs to small a belongs to t is a terminal and alpha is a string of 0 or more variables. So alpha can also be epsilon or it can be more variables. So it is capital A followed by a small a or capital A followed by a b. These two are allowed. So it can be either epsilon or it can be more than 1, more than 0. The language L of G should be without epsilon. Right hand side of each production should start with a terminal followed by the string of non-terminals of length 0 or more. So it should always have a terminal. The right hand side should be having a terminal followed by a non-terminal of either epsilon or more. So I said that there can be A only, that means there is no non-terminal. Non-terminal is a 0, or it can be A with a AB, where A is a terminal, small a is a terminal and capital B is a non-terminal. So next is removing left recursions. Elimination of left recursion is an important step in the algorithm used in the conversion of CFG into GNF form. Left recursion grammar, a production of the form A, capital A, gives capital A and alpha is called a left recursion, as the left hand side variable appears as the first symbol on the right hand side. So left hand side variable appears as the first symbol on the RHS. This is the left hand side variable and it is the first symbol on the RHS. Language generated by left recursive grammar. Let us consider a CFG containing productions of the form A giving A, capital A alpha, capital A giving beta. The language generated by the above production, capital A giving alpha, capital A giving 2 alphas, capital A giving 3 alphas, capital A giving capital A alpha raised to any number. So n, we say alpha raised to n means any number of alphas, beta alpha raised to n, any number of alphas. So algorithm for conversion of CFG to GNF. So in short, when do you say that the grammar is left recursive? Let's see that first. So for example, if I say that you have A1, A1, or no, wait. Suppose I say you have A1 and it is giving you A1, A1. So here this is considered as I, this is considered as J. I equals J. We say that this grammar is left recursive and you have to remove this left recursion. You don't want this I and J to be equal. So this condition, when this happens, we say it is left recursive grammar. And how do you remove the left recursion? You introduce a variable. Simply introduce a variable. So for example, if I introduce a variable, say Z, then I say Z will be A1 Z, or I can say only single A1. So this A1 will be replaced. This A1 has to be replaced. So just write this A1 as it is and with us followed by a Z, or you can just write a A1 without that variable. So we'll see this ahead. Much more clarity will happen. You will get a much more clear picture. Algorithm for conversion from CFG to GNFR. So first step is eliminate epsilon productions, unit productions and useless symbols from the grammar. Second step, in production of the form A giving x1, x2, xj till xn, other than x1, every other symbol should be a variable. x1 should be terminal. So we know that in Greibach normal form GNF, we say that your first symbol should be a terminal. So they're saying x1 should be a terminal symbol. Example, consider a production A, V1, V2, A, V3, B, V4. Terminal symbols A and B can be removed by rewriting the production having CA and CB. Thus, at step 2, all productions must be of the form alpha. A given, A is giving you alpha, capital A is giving you small a, and capital A is giving you small a alpha, where small a is a terminal and alpha is a string of non-terminals. Rename variables as A1, A2, A3 till AN to create A productions. So next step is to rename the variables. Consider this grammar. The variables are S. If you see, first variable is S, second variable is X, third variable is Y. So S will be renamed, X will be renamed and Y will be renamed. So we say that X is A1, S is A1, X is A2, Y is A3. So it is renamed as A1, A2, A3 respectively. So you have to rename it according to the ascending order. First S is appearing, so S will be renamed as A1. Second X is appearing, X will be renamed as A2. Third Y is appearing, so it will be renamed as A3. So always rename in the ascending order of their appearance. The productions will become A1. S will be replaced by A1. So A1, then small a, then A2, because X is replaced by A2. S is replaced by A1. So again A1, Y is replaced by A3. So A3 slash Y is replaced by a A3, S is replaced by a A1 and X is replaced by a A2 slash a small b. So we have to rename the productions. Which productions? The non-terminals. So what will you rename as A1, A2, A3? The non-terminals will be renamed and they will be renamed in the ascending order, not in any order. So you cannot give S as A2. You have to give S as A1 only. Modify the productions to ensure that if the production AI greater than AJ alpha, then I should be less, so J should be greater than equal to, I should be less than J. So basically what are they saying? That your I should be less than equal to J. If there is a production AI giving you AJ alpha where I is greater than J, then we must generate production substituting for A of J. So if suppose there is a production, say, if you see this case, A1 giving you A, A2, A1, A3. Here your I is 1 and your J is the first, that is your 2. So J is 2, so J is greater than I, so this is your accepted one. If you see this, A1 giving you A3, A1, A2. Again, I is smaller, J is greater. Again, this is also accepted. You don't have to bother about these two. You only have to bother about the first non-terminal. But if the situation is something like this, A2 giving you A1, A3, A4, then here your I is 2 and your j is 1. You don't have to bother about these two. Here you see that I is greater than j, then this is not acceptable. So then we will have to apply certain rules which will have to be followed to remove that. So you have to substitute a of j. Aj in that case generate certain production substituting for aj. If such a condition occurs where I is greater than j, like this, 2 is greater than 1. So I is greater than j, so it is not acceptable. Step number 5, repeating step number 4 several times will guarantee that for every production a of I, a of j alpha, j is greater than equal to I. Step number 6, remove left recursions for every productions of the form a of k, giving a of k alpha. B production should be added to remove the left recursions. So let's see the sixth point now. If we consider the sixth point, then they are saying to remove the productions which have left recursions. So how to identify that? Sixth, a of k giving a of k and alpha. That means a of 1 giving a of 1 and alpha. Here if you see, I and j become equal. So whenever you have this condition where both of them are k, means both of them have the same value, then we say it is a left recursion. In this case, what you have to do? G and F does not allow left recursion. So you have to remove left recursions because G and F does not allow the left recursions. Modify A of I productions to form A of I giving small a alpha, where a is a terminal and alpha is a string of non-terminals. Modify B of I productions to form B of I giving a small a and alpha, where a is a terminal and alpha is a string of non-terminals. So after you have removed the left recursions, ensure that your RHS value in the RHS and LHS you have, so this should be always greater, j should always be greater than I. So your RHS value should be greater than your LHS value for the first symbol. But this does not mean that this form is a GNF form. This is not a GNF. To convert it into GNF, you will need the non-terminal. The first symbol should be a terminal. So you will need a terminal. When will this be a GNF? When you have A2, B, A3, A4. So your B is your terminal. That's when you will say that this is your GNF. So all these steps have to be followed. So we will see the examples. It will be much more clear.